In this video, I'm going to explain the concepts of positive and negative feedback, and I'm going to do that with a little plant watering system. So in my system here, I'm trying to drip water onto my plants at the correct rate, and to do that, I've got a tank with some water in it, and if the tank level is correct, then it creates the right amount of pressure to drip the water out at the right rate. Now to control the tank level, I've got this little control system up here that controls the level of the tank. So what happens in my control system is that if the water goes up, then this little float valve goes up with it, and the pivot arm goes up on this end, and it goes down on this end. Well, if the pivot arm goes down on this end, well, it closes my little gate off here, and it reduces the amount of water entering the tank. So if the water goes up, the gate closes. If the water goes down, well, then the float goes down, pulls down the pivot arm, and if it pulls down the pivot arm, this side goes up. That will open the gate, and when I open the gate, more water will rush into the tank, and it'll fill it up until it closes the valve again. So what I'm doing here is I am sampling the output with the float valve and using that to create a signal that is fed back into the input that will increase or decrease the output. This is negative feedback. An increase in the output causes a decrease in the input. Negative feedback results in a stable system. The tank level will be maintained at a constant value. Now let's take a look at positive feedback. In a positive feedback system, what I've done is I've rearranged the pivot arm so that the pivot point is at this point and the float valve is in the middle. So what'll happen here is that when the float valve goes up, the gate goes up with it, and this will result in more water pouring into the tank. So essentially what'll happen is that if the level rises, I will increase what's coming in, which will make the level rise even more. This is positive feedback. An increase in the output causes an increase also in the input, and what will happen with positive feedback is that tank will either empty or it'll overflow. Positive feedback results in an unstable system. The tank will either fill up or it'll empty, and then it'll just sit there. So how does this apply to op-amp circuits? Well, let's take a look. But first, let's go over the 3 basic rules of op-amp analysis. Number 1, gain is huge. The output of the op-amp will swing in the direction of the input that is greatest. So what that means is that it will go up when the positive input is greater than the negative. It'll go down when the negative input is greater than the positive input. Number 2, the inputs of an op-amp are high impedance. There is virtually no current that flows into them. So you can think of the input of an op-amp as essentially being an open circuit, and there will be no current that flows into the input. And then number 3, with negative feedback, the op-amp will adjust the output until the inputs are equal. Let's use this circuit to work through an example. The positive input is connected to ground, and so that means that the ground always has 0 volts on it. The negative input is connected to a 1 k ohm resistor, and that 1 k ohm resistor is going to get connected to some other source, let's say 1 volt. Now up over here we have a feedback resistor, which currently hasn't been connected. So since the negative input is currently greater than the positive input, the output is just going to swing down to the most negative value. If I'd made that input minus 1 volts, then the positive input would be greater and it would swing in the positive direction. So without feedback, the op-amp is toggling back and forth between the positive and negative output depending on which input is greater. Let's see what happens when we add in some feedback. So to add some feedback, what I'm going to do is I'm going to connect this side of the resistor to the output, and I'm going to use that to sample off some of the output and then feed it back in here to the input and mix it in with the 1 volt coming in through the 1K. So now we've given that current that's coming in, we've given that current someplace to go. It can bypass the input and work its way around here to the output side. And when it gets to the output, what ends up happening is it goes into the op amp and it either goes down to the negative supply or it goes up to the positive supply. So to think that it's connected to the output, that it doesn't go anywhere, well, the output is basically feeding it back to one of the sources. So with feedback then, the input will pass through the 10 kilo ohm resistor and will make its way to the output. It will do this because we applied a positive voltage on the input, and that goes to the negative input of the op amp, which makes the output swing down. So the output is going to a negative value, and the input current will flow from a positive, it will flow to a negative voltage. So the current will go through the feedback resistor. As it goes through the feedback resistor, it will create a voltage across the feedback resistor with this polarity, and it will continue to do that until this point right here gets dragged down to 0 volts. So the next question is, well, what voltage on the output, what voltage over here will cause the point in the middle to be 0? From that, we can look at the currents. We put in 1 volt on the input into a 1 kilo ohm resistor. This resistor here has 1 volt on one side and 0 volts on the other. So there is 1 milliamp of current flowing into the circuit. That current gets bypassed through to this resistor. And if there's 1 milliamp of current going through a 10 kilo ohm resistor, then that resistor will have 10 volts across it. Since this point is held at 0 volts, then the output of the op amp has to swing down to minus 10 volts to get that input to 0 and to make everything stable. So, in summary, the input goes up to 1 volt. Current gets rerouted through the resistor, and it's 1 milliamp of current that results in 10 volts. The output drops, and it drops down to a point, which is 10 volts, which makes the point in the middle 0, which matches this voltage over here. And when the outputs of the op amps are the same, it won't swing in either direction. You've reached a stable operating point.